So let's look at an example of how we would actually use the trigonometric ratios to find the sine, cosine, tangent, so forth and so on. We'll look at an example here, and then we'll look at some more when we meet each other face to face. So in this example, we want to find the 6 trig ratios or 6 trig functions of a standard position angle theta, whose terminal side passes through the point 1, 3. If you remember, when we were referring to standard position angles, we are talking about the one whose vertex is at the origin and its initial side is on the positive side of the x-axis. So if you look at the drawing that I'm constructing now, that's the y-axis. Of course, this is the x-axis. I'm going to draw this angle in red. So its vertex needs to be at the origin. Its terminal side needs to be on the positive side of the x-axis. And the terminal side is going to pass through the ordered pair 1, 3, which means this would be a first quadrant angle. Okay, and let's say that this is the point 1, 3. All right, and then this would be angle theta. Okay, so we want to find the 6 trig ratios of angle theta, and remember the properties of the similar triangles. Okay, the sides would be proportional, so they would have the same ratio. So we can actually draw this side anywhere, and this is our right angle. So the horizontal length, or the length of the leg, one of the legs of this right triangle is 1. Okay, because to get to the ordered pair, we move to the right 1 and we move up 3. And the vertical length or distance is 3. All right, so we want to use the trig ratios. But first we have to understand that we need to find the length of the hypotenuse. And we're going to have to use the Pythagorean theorem for that. So the hypotenuse is going to be found by using the Pythagorean theorem, which says the hypotenuse squared equals the sum of the squares of the legs. Usually you'll see this written as c squared equals a squared plus b squared. Okay, so our hypotenuse, which is still our unknown, would be c squared. It's going to equal the legs are found adjacent to the right angle, or this leg is 3, the other leg is 1. So c squared is going to equal 1 squared plus 3 squared, which means that c squared equals 1 squared is 1, 3 squared is 9, 1 plus 9 is 10. So c would equal the square root of 10, because remember, the inverse of squaring is to take the square root. So that means the hypotenuse has a length of the square root of 10. And we're going to use each one of these lengths to find the trig functions. We'll start with sine. Remember sine, the sine of theta would be its Oscar hat or opposite over hypotenuse. So here's theta. The side that is opposite it cannot touch it, so it would be the side that has a length of 3. and the hypotenuse is the square root of 10. So the sine of theta equals 3 divided by the square root of 10. We use the same triangle if we want to find the cosine of theta. Cosine of theta is a heap, or adjacent over hypotenuse. Again, theta is here. The side that's adjacent to it is the other leg that actually touches theta, okay, which is 1, has a length of 1, and the hypotenuse has a length of the square root of 10. So the cosine of theta equals 1 divided by the square root of 10. Tangent is of apples, opposite over adjacent. I'm going to scroll back up so we can see the drawing. And this, again, is on page 5 of your notes. So if we want to find the tangent, again, we're doing opposite over adjacent. And here's theta, opposite is 3, adjacent is 1. So the tangent of angle theta would be 3 divided by 1, which is just 3. Okay? Now we want to find the inverse of the trig functions. We want to find cosecant, secant, and cotangent. Okay? There's several ways you can do it. I'm going to show you 2 ways, and I'm going to start with the way that I think is the most straightforward. So remember that cosecant is the reciprocal of sine. So cosecant is the reciprocal of sine. Sine equals 3 divided by the square root of 10. So the cosecant is going to be its reciprocal, or its inverse, which is 1 divided by 3 over the square root of 10. And all this does is flips the fraction upside down. So the cosecant of theta would be the square root of 10 over 3. Compare these two. Okay, the sine of theta was 3 over the square root of 10. The cosecant of theta is the square root of 10 over 3. It just flipped it upside down. They are reciprocals. The same is true for cosine. Its reciprocal is secant. So the secant of theta would be the square root of 10 over 1. Because again, we're taking the ratio we got from cosine and inverting it, or finding its reciprocal. And lastly, the cotangent of theta would be the reciprocal of 3 over 1, which is 1 over 3.